Welcome back to the course Computer Programming. In the first part of this lecture, I will go over modules in Python. To understand this lecture, my assumption is that you are already familiar with conditions, loops, list, function, and exceptions in Python. In the previous lectures, we learned that we use if else statements to make decisions. We turn patterns in several continuous lines in a code into for or while loops. We learned that if the patterns are in the name of the variables, we turn them into one-dimensional or two-dimensional list. And we also learned that if patterns are at different parts of the main code, we turn them into functions with parameters, arguments, and return statements. We also learned that we need to use a try except to handle runtime errors so that Visual Studio Code itself doesn't show error messages to the user, and we as the coder show customized error messages to the users. After this lecture, you can explain the differences between front-end and back-end programmers. You can explain how modules help these two types of coders to communicate and use each other's codes. You learn how to create and use a module. You can also handle runtime errors so that, in a way, the two types of programmer can communicate. First, pause here for a minute and try to create a function called isInList, which check if the second argument given to the function exists in the first argument given to the function, which is a list. So in this case, if you run the test code seen in this slide, you should receive the output of false and true, since 9 does not exist in the given list, but 5 exists in the given list. If you can create this function, that means you're ready to learn modules. Here is the answer to this exercise. As you can see here, this is the part that is written by a coder programmer by you, and this is the output, which is, the user part, is the perspective of the user. The user gets the Python program from the coder and tries to run it in a development environment to see what the output is. So far, we learned about two roles during these lectures. The coder, who is a person that writes the code, and user, who is the person that runs the code. The coder uses print to show a message, a result, and output to the user. The coder also uses the input function to get input from the user. You learned about these two in the first lecture. In reality, we have two types of coders. What you already know is the front-end coder. Front-end coder is the person who writes the code that interacts with the user using print and input. For the sake of this presentation, we are going to call him the American coder. Backend coder is the type that you're going to learn about in this presentation, in this lecture. He is the coder that writes the code that supports the front-end coder. So for some codes, the front-end coder, the American coder, perhaps does not know how to do that, or he doesn't have time to do that. He uses the code that is created by the backend coder. For the sake of this presentation, we call the backend coder the Dutch coder. This presentation is about how backend coders and front-end coders communicate with one another. I'm going to use the example of fraction operation in the next slides. You already learned, how to add two fractions, in the past during the primary schools, hopefully. We have a numerator and a denominator for each fraction. So to add two fractions, you have to multiply the two denominators to calculate the new denominator, and you need to multiply the numerator of the first fraction by the denominator of the second fraction, and then you do the same for the denominator of the first fraction and the numerator of the second fraction, and then you add them, and the result, as you can see here, is 28 over 32. We need to simplify this fraction, and for that we need to calculate the greatest common divisor, which we call GCD here. For 28 and 32, that's 4, so we use 4. We divide the numerator 28 by 4 and the denominator 32 by 4, and the simplified uh, outcome is 7 over 8. So as you can see in the black part of this slide, our program gets the first fraction 3 over 4 and the second fraction 1 over 8 and calculates the sum, which is, in this case, C1 and C2. So we are assuming that we already have the functions. The functions GCD, as you see here, it calculates the greatest common divisor, and the function simplify gets two parameters. It calculates the GCD, and then it divides the numerator and denominator by the GCD, and it returns the simplified version of uh, the fractions, the outcome. So here in the main part of our program, we get the inputs A1, A2, B1, and B2. We do the calculation for summation according to what we just saw here. And then we use the simplify function to uh, simplify C1 and C2, and then we print it, which is 7 over 8 in this case. So if 28 is given as the result for C1 and 32 is given as the result of C2, the denominator of the outcome, then 28 and 32 are given to the simplify function. In the simplify function, the GCD function is called, and 4 is calculated using this function GCD, and then 28 and 32 are divided by 4, which 7 and 8 are the result, and these 7 and 8 are returned to the main body of the code, and they are stored again in C1 and C2. So as you can see here, this simplify function works like this visual presentation. Assume that we have one programmer in the Netherlands and one in the United States. The American programmer is willing to pay the Dutch programmer to have the simplify and GCD functions that we just learned in the previous slide. He may have two reasons for that, either for financial reasons, since the Dutch programmer are cheaper, so he'd rather have the Dutch programmer uh, create these two functions, or the American programmer does not know how to do that. So the Dutch will create a file that contains these two functions, and you need to know that this file is called module, and he will email that file to the American programmer. So the Dutch is going to call this file mdlfraction.py. It includes GCD and simplify. With that file, which is a module, he also sends a manual to teach the American programmer how to use the functions and what kind of runtime error may occur during the usage of these two functions. The American will create a file, assuming called main.py. which uses the Dutch file mdlfraction.py in the main.py to create the program that the user wants. So the American has a file called main.py, and this file uses GCD and simplify functions that are stored, that are written in the Dutch mdlfraction.py. So the user will receive two files, but he will run the main.py. So the user receive both mdlfraction.py and main.py, but he will run the main.py created by the American. We want to learn how the Dutch programmer, the backend programmer, creates the module, and how the American programmer, the front-end programmer, uses that module. Okay, you're the Dutch programmer. How do you create the module? First, you need to create a file with .py extension. This is very important. You cannot use, if you're using Jupyter Lab, you cannot use .ipynb file. You only need to have a .py file, and you can call it whatever you want. In this case, I'm going to call it mdlfraction.py. You move the functions, or you create the functions which you are paid for to this file. You test the function to make sure that that the functions are working. Then you remove the test code, which means the don't domain part that you use to test this code. So you save the file and you email it to the American programmer or the front-end programmer. So again, make sure that mdlfraction.py must be sent to the American programmer. Now you're the American programmer. You need to download the module sent by the Dutch programmer and put that file next to your own file, which is in this case main.py. Note that some modules are already downloaded and already exist in your computer when you installed Python modules like math. So you don't need to download them. In your code, you need to mention that you would like to use the functions or classes in the given file. So the name of the file is mdlfraction.py. You will write down import mdlfraction. You shouldn't write the .py part. Or you can give this file, this module, another name. Import mdlfraction as frc. So I gave this module an alias, another name. Then after you wrote down the import part, you can use the functions with a prefix as follows. So if you wrote down import mdlfraction, then you need to write down mdlfraction.simplify to use the simplify function defined in this module, and give C1 and C2 as the parameters. If you gave an alias to this module, such as frc, then you need to use frc.simplify to use the simplify function. So note that you can also use other functions that exist in this module. This is just one example of using a function that exists in a module. You can also use functions in a module without providing the prefix. In your code, you can use the keyword from, then the name of the module, which is mdlfraction here. After that, the keyword import, and after that, you can write down the name of the function that you want to use. If you want 2 or 3 functions, you can use them separated by comma. So after that, you can just easily use simplify without mentioning the prefix. Note that if you write only simplify in the import clause. You cannot use GCD. If you would like to use all functions in the module in place of the in the import clause, just place asterisk, and that means you want all the functions. Before writing a function, you need to make sure that it is not already written by someone else. So it's a good habit to always search the internet and make sure that a module, a package does not exist that includes a function that does what you want. So, for example, you see that the Dutch programmer here created the function GCD and put it in the MDL fraction. But if he was searching before creating this module, this function GCD, he would figure out that the function GCD already exists in another module that is already uh, exist in all computers that have Python. That module is called math. So the Dutch programmer could easily sell math to the American programmer without even trying to work on this, creating a function from the scratch. So keep that in mind that you don't need to always write the functions from scratch. You can easily use import for example, in this case, import math in your function. So even your module, the module that is created by a backend programmer, can use a module that is created by another programmer, which we called for the sake of this presentation the Indian programmer. So as you can see here, we are going to have three layers of coders: the American coder who is the front-end programmer, the Dutch programmer who is who is supporting um, the American programmer, the front-end programmer. The Dutch programmer is the back-end programmer. The Indian programmer is also a back-end programmer, and he creates a module that is used by the Dutch programmer. Sometimes you find codes using Google or Stack Overflow that use new modules, that imports new modules. For example, you see here that there is a module called PyPrimes, and I imported that PyPrimes. It gets a number and it uses the function is prime in PyPrimes to figure out if a number is prime or not. So you try to execute this code using Visual Studio Code or Jupyter Lab, and there is a chance that the development environment returns Python returns module not found error. That means the module does not exist, and in that case you need to install the module once so that you can use it as many as you want, as many times as you want. So how can you install that? You can write a code inside your Visual Studio Code and run it just once, and then you are fine for the rest of the, as long as you have the same, as long as you have that computer. So you write down import pip and then pip main install q and pyprimes, and that will allow you to install the module. You can also use the terminal uh, menu in Visual Studio Code, new terminal, and then there you can type pip install pyprimes, and then press enter, and this will really install the package. The new package will be installed for you. The new module is going to install for you. So when you install a package, when you install a new module, you will see, the package. If you are using Anaconda, in the Anaconda folder inside program data inside C, at least that's where I see them. And inside that folder, you have lib and side packages, and there you can see all the installed modules and packages. There is a chance that what I suggested in a previous slide does not work for you. In that case, first try to make sure that Anaconda is installed, because that makes your life way easier. Anaconda has so many packages, and if you install VS Code after Anaconda, then you already get connected to Anaconda, and then you have most of the packages. But if that doesn't work for you, look for pip.exe in your computer. Mine is in the past C program data Anaconda 3 scripts. It should be something similar for you. So just copy the path and put it in the a command prompt. You can just click on Windows Start menu and then type CMD and press enter. There, just type cd and then copy paste the path where pipe or pip.exe exists in. Now, um, in the command prompt, you can just simply type pip install package name and then the package can be installed. Still, that may not work for you. Then you can use, what I suggested in this slide. Now that you know how to create modules and how to use modules, here I would like to explain how you can communicate runtime errors that occur inside a module code. Let me remind you about our example first so that I can make sure that you get the next slides. We had three roles involved here. The user who would provide inputs and would like to see the output. Here the user wants to provide two fractions, the numerators and denominators of the two fractions, 3 over 4 and 1 over 0, and he would like to see the result of summing the two. Note that 0 cannot be accepted as a denominator. So normally, the American programmer who is in charge of interacting with the user must have a kind of code in main.py that would check if B2 or A2 are equal to 0, and if they are 0, the program should be terminated and a print message should be shown to the user that the denominators cannot be 0. However, in this case, the American programmer were silly and forgetful, and he didn't do that. As you can see, he gets A1, A2, B1, and B2. If the program calculates the new fraction, and then it calls the simplify function. Here, as you can see, the simplify function will call the codes that were created by the Dutch programmer, the MDL fraction.py. So what happens here? You see here that C1 and C2 are given to the simplify function. The Dutch programmer knows that C2 cannot be 0. How can the Dutch programmer tell the American programmer that C2 cannot be 0? Can he use print function? Here we want to learn how the Dutch programmer, the backend programmer, can inform the front-end programmer, the American programmer, about a runtime error. So assume that the manual by the Dutch says that C2, the denominator of the fraction in the simplify function, cannot be 0. We know that we cannot have a fraction with 0 as the denominator. So imagine, nevertheless, the user gives 0 as a denominator after running the main.py created by the American programmer. So user will, as so there is a function, there is a program main.py that has an input function. The input function is executed and it asks for the not for the numerator and the denominator, and the user will provide 0 as for the denominator to the main program. So what happens here is that main.py takes the input and calls simplify function in the MDL fraction, which created by the Dutch programmer. So it just simply, without checking if the denominator is 0 or not, it directly sends 0 to the simplify function in the MDL fraction. So the thing is here, the Dutch programmer, the one who is creating the module part, he cannot use print to inform the American programmer about the error because print shows the error message to the user, not it doesn't show the error message to the American programmer. Uh, so printing error is unprofessional. So inside modules, usually inside functions, we it's a general good practice to not use printing whenever you bump into an error message. So what should I do then? You need to use the raise exception uh, command to inform American about the error message. So you need to use raise exception, and with raise exception, the Dutch programmer is talking to the code written by the American programmer. And then the American programmer can see what type of error message occurs, and he uses try except to print an error message that is customized for this user. So it's unprofessional for the Dutch programmer to print an error message. Uh, he needs to raise exception. So the Dutch programmer has to use raise exception in place of printing. We learned in lecture 3 on errors in Python that the front-end programmer can use try except to handle the exceptions, the runtime errors, so that he can uh, print customized error messages. So how the two communicate here? Dutch programmer, the backend programmer raises exception. The American programmer, the front-end programmer uses try except. So the Dutch programmer can use two different approaches in raising exceptions. First, he can use the standard Python error message. For example, for zero division error, we already have this standard Python error object in Python. So you can simply use raise zero division error. But if you would like to send a customized message to the American programmer, then you can use raise exception and add parentheses, and in between parentheses you can write down your message to the American programmer. Then the American programmer can read that message using try except. So that's how you write the first option when you want to use the error object that is already created by the Python. In the simplify function, the Dutch programmer check if C2 equals to 0, then raise zero division error. So you just need to use the raise clause, and inside, in the raise clause, provide the runtime error that already exists in Python. As for the second option, as you can see here, if C2 is equal to 0, then we say raise exception, and in between the two parentheses, we provide the exception that we want the American to see. We are assuming that the American programmer knows Dutch, so here I mentioned C2 kann nicht null sein. So if the Dutch programmer raise exception as you just saw in Dutch language, passing on a message in the Dutch language, then the American programmer can be careless and do not check anything. If he doesn't check anything and it gets a 0 from the user, then the result would be something like this. The first line is going to provide 3 and 7, and it's going to be printed. the next line will create a runtime error, and a Dutch sentence is shown to the American user who has no idea, who doesn't speak Dutch at all. So that's why you need try except in the main.py so that you can show a message that the American programmer can understand. So again, the American requires to handle the exceptions. If the Dutch uses an existing exception like raise zero division error, he has to explain that in the manual. One way to do that is to just mention that in the doc string, where right after the signature of the function, you use triple quotations and you explain what the function is about, and there you explain what type of runtime error can occur uh, using this function. So that's what the Dutch programmer needs to do. Now the American programmer has to use a way to get this message to be. He needs to be. He needs to think that he needs when he reads manual. He needs to ensure that he can catch the runtime error that can happen. How can he does that in his main.py? He uses try except, and in the except part, because the Dutch programmer in the manual in the doc string mentioned that zero division error can happen, he uses except zero division error and then colon, and if something happened, if that error happened, it says print c2 cannot be zero. However, Uh, just note that, for the simplicity, we didn't use int input. We just directly use the numbers so that, the program can be easier to understand. Keep that in mind. So if the runtime error occurs in the second line, as we learned in lecture 3, the program jumps to the zero division error part and it prints C2 cannot be zero. Therefore, the line print simplify 812 will not be executed at all. So as a result of that, a user will see 3 and 7 for the first simplify function, then he'll see C2 cannot be zero, and then the end will be printed. However, if the Dutch programmer raises a new customized exception, as you can see here, the American can read his or her message as follows. So in main.py, again, try except is used, but this time you need to use exception. Because you don't have an error, an exception that already defined in Python. This is a customized exception. So you would say that exception as E, and then if you use str E, the str function can turn that error message into a string. You can use if to figure out what type of error message that is, and then use print to show a customized error message to the user. So in this case, as I explained, E includes Dutch programmer's message, and as a result, you can see here 3 and 7 is printed as a result of the first simplify function, 12 and 28. Then the second function returns runtime error because of the raise exception in Dutch code, in Dutch programmer's code, and therefore simplify 8 and 12 is not going to be executed. The program jumps to the except exception as E. The error message can be seen is stored in the E, and now you see here that print error C2 cannot be zero, and then STRE, which means the Dutch version of uh, the Dutch version of the Dutch translation of the the error is also printed here by the American user. Of course, we do not, I won't suggest this, but this is a way that, this programmer did this. So in summary, modules are mainly used to share functions, and later we learn classes and also share classes. In one module, you can have one to many functions, and we can easily get a module from another programmer and use the functions that he already created in our own program. That makes programming easy and, more importantly, cheap. Using other people's code can help us to create more value for our organization. You need to keep in mind that as a backend coder, you always use raise to inform the front-end coder about an error. In the appendix, I went over packages and passing function as arguments. Here I explained what a package is and how a package may look like. Here I explain how you can give another name to a function and how to pass function as an argument. If you have any questions, you can ask them during the interactive lecture.